The next and another interesting chapter is network theorems. What is this network theorems? You might ask, why theorems? Frankly to speak, first before we get into this theorems part, let me tell you, there are 9 theorems in our syllabus. I can say Telegin's theorem, superposition theorem, Thevenin's theorem, Norton's theorem, Millman's theorem, dual of Millman's theorem, reciprocity theorem, maximum power transfer theorem, and compensation theorem. Of course, you also have something called substitution theorem, right? So these are all the different theorems what we have as a part of our GATE syllabus, or in fact, you can take any examination, you can expect a question from all these theorems. So first, why theorem? Why should we learn theorem? Let me answer this question with the help of one simple example. I'll draw one simple diagram. Suppose if I show you this diagram, if I say this is x, this is y, and what is this, then what is going to be your answer? Without putting pen on paper, you are going to answer this as what? Under root of x square plus y square. Right? Right? So without putting pen on paper, without doing any analysis, without doing any calculation, immediately you are going to say as what? Under root of x square plus y square. If I ask you how, then immediately you are going to say according to Pythagoras theorem. So what I am trying to say is, theorems are the outcomes of the experiments. Already Pythagoras has done a lot of experiments and finally concluded that from now onwards, whenever you come across a shape called right angle triangle, if one side is x, other side is y, then the longest side is going to be what? Hypotenuse, that is under root of x square plus y square. If somebody asks you how, simply you have to say what? According to Pythagoras theorem. So theorems are the outcomes of the experiments. So here also Kirchhoff, Millman, Thevenin, Norton, Telegin, there are different scientists have done different experiments, and they concluded their experiments with some conclusions, and those conclusions we are learning as statements, right? Let me put it this way. There is a special way to learn theorems. If you learn theorems, then automatically you can answer question very comfortably, right? In fact, there is no wonder that theorem is also one of the powerful technique for us to solve circuits. Okay, for example, in the question, he'll simply ask you find current. He won't say find current using Thevenin's theorem, using Norton's theorem, using this theorem, that theorem. He's not going to say. He's going to simply say find current. Whether to be used nodal analysis or mesh analysis or superposition theorem or some other theorem, that is your decision. Okay. Now, as I said, there is one special way to learn theorems. If you learn theorems in that way, then you can answer any question related to especially theorems. How to learn is, first, as I said, there are 9 theorems. First, let us pick a theorem, understand what that theorem trying to convey, and most importantly, let us learn its application. Means which theorem to be used where. All these theorems has got very interesting and very specific applications. For example, there comes a situation where other than superposition theorem, all doors are closed for you. The only option left out for you is superposition theorem. Seriously. There comes a situation where other than maximum power transfer theorem, you cannot answer that question at all. There comes a situation where other than Norton's theorem or other than reciprocity theorem, you cannot answer that question at all. There comes a situation, you can answer that question in the shortest possible time if you select a theorem called Thevenin's theorem. So, as I said, total there are 9 theorems are there. There are 9 different situations or 9 different applications. What if you memorize those applications, or what if you memorize those situations? Have you memorized this? For example, the moment I shown you this figure, did you recollected superposition theorem? No, right? Because you memorized that, chalo, right angle to triangle, then the theorem to be recollected is Pythagoras theorem, right? Similarly, here 9 theorem has got 9 interesting applications, 9 interesting situations. All these 9 situations you have to memorize it, so that whenever you come across that situation, Directly you can say according to superposition theorem answer is so and so. According to Telegin's theorem answer is so and so. According to Millman's theorem answer is so and so. Alright. So, this is the way to learn theorems, and very important topic in terms of examination point of view. Compulsory questions you can expect in these theorems.